Let us talk about the architectural patterns. First is the monolithic architecture, where the entire application, like user interface, business logic, and data access, lives in a single code base and is deployed as a one unit. It's simple and easy to build small apps. Tools like Spring Boot, Ruby on Rails are popular here. For example, early versions of platforms like WordPress or Instagram were monolithic, but app grows. These monoliths becomes hard to scale and maintain and risky to update. To manage this, we move to the client server architecture. This splits the system into two major parts: the client, such as mobile or web app, as a front end, and the server, which handles the backend logic and data. Think of mobile apps using the REST API or GraphQL to talk to Node.js, FastApp, or .NET Server. Applications like Gmail or Facebook follow this model. While it improved separation, the tight link between the client and server still made changes complex. Next came the n-tier architecture, commonly used in enterprise app systems. Here we organize the application into multiple layers: presentation, business logic, and data. Tools like Java EE, ASP.NET MVC, or Spring MVC makes this possible. For instance, many banking systems or ERP platforms still rely on the n-tier setups. It improved modularity and testability, but deployment remained heavy and not very agile. As business demanded faster delivery and better scalability, the microservice architecture emerged. This breaks the app into small, independent services that run separately but work together. Each service can be built with different languages or take like Spring Boot for one and Go for another, and communicate using REST, gRPC, or message queues. Tools like Docker, Kubernetes, Consul help manage them, and companies like Netflix, Amazon, and Uber successfully run on microservices. While powerful, this approach adds a complexity in server coordination, deployment, and monitoring. To improve the flexibility and build more decoupled systems, we moved to the event driven architecture. Here, the services communicate through events rather than direct calls. For example, when user signs up, as a user registered event is emitted, and other service like email or analytics listen and respond. Tools like Apache Kafka, RabbitMQ, and AWS SNS simple notification service are popular for the event streaming and messaging. This model powers systems like Slack notifications, e-commerce order flows, and IoT platforms. It scales well but requires strong observability and error handling strategies. Finally, we reach a serverless architecture where developers focus on writing small piece of code called functions, while the cloud handles everything else like infrastructure, scaling, and uptime. Tools like AWS Lambda, Azure Functions, and Google Cloud Functions enables this. Use cases include API's imaging process, background jobs. For example, Netflix uses serverless for real-time encoding and automation tasks. It's fast, cost-efficient, and ideal for event-based workloads, but comes with limitations like cold start and execution timeouts. In summary, from monoliths to microservice to serverless, software architecture has evolved to solve the challenge of flexibility, speed, and scale. The right choice depends upon your project's need, but knowing these patterns, tools, and examples will help you make smarter decisions as system continues to grow and more intelligent and dynamic.